Okay, so we're going to continue working on linear programming, but now we're going to look at word problems involving linear programming. So with these ones, they're not going to automatically give us the constraints and the objective function. We're going to have to figure out the constraints based on the information they're giving us in the word problem. We're going to have to write the objective function. So these ones are a little bit more involved at first, but we want to break down the information. So the very first thing that I hope you see up here in big, bold, pink lettering is read the whole problem first. So let's read the whole problem first before we start jumping into just grabbing information, because I can already see a whole bunch of numbers there. But I need to read the whole problem first, make sure I understand what I'm being asked to do. All right, so a mining company owns 2 mines. The mines produce an ore that can be graded into 2 classes, regular grade and low grade. So that's the same idea that we had on previous ones when I was talking about things like we have a higher quality product and a lower quality product. So the company must produce at least 420 tons of regular grade and 450 tons of low grade ore per week. The first mine produces 6 tons of regular grade and 18 tons of low grade ore per week. The second mine produces 18 tons of regular grade and 9 tons of low grade ore per week. So we're already getting a lot of information. So that's why we're going to break it down here in a moment. The operating cost of the first mine is $19,000 per hour, and the operating cost of the second mine is $13,300 per hour. The first mine can be operated no more than 40 hours per week, and the second mine can be operated no more than 38 hours per week. How many hours per week should each mine be operated to optimize costs? Operate to minimize the costs. I don't know why I said optimize costs. So note the ALEKS graphing calculator can be used to make computations easier. I don't recommend using the graphing calculator on ALEKS on this one. I actually would recommend using the graphing calculator I'm going to show you how to use called Desmos.com. The graphing calculator for ALEKS can be a little bit more difficult in my opinion because it doesn't let you put in certain types of constraints like the x is less than a number or x is greater than a number. You have to draw those in yourself. It's also not going to automatically show you the shading. You're going to have to know which way to shade. So I think Desmos.com is just a little bit nicer to use than ALEKS, just in my opinion. So before we start filling this in, I kind of did a little color coding to kind of help break it apart just a little bit more. So if we identify the important information, if we look at what information is just for mine number 1. So if we reread this, we're going to have a mining company owns 2 mines. The mines produce an ore that can be graded into 2 classes, regular grade and low grade. The company must produce 420 tons of regular grade and 450 tons of low grade ore per week. So far I haven't heard anything specific to first mine, second mine, but this next sentence is going to be specific. The first mine produces 6 tons of regular grade ore and 18 tons of low grade ore per hour. So that's specific to the first mine. The second mine produces 18 tons of regular grade and 9 tons of low grade ore. That's specific to the second mine. The operating cost of the first mine is $19,000 per hour. That's specific to the first one. And the operating cost of the second mine is $13,300 per hour. So that's specific to the second mine. So they're kind of giving us chunks of information in each one. The first mine can be operated no more than 40 hours per week. Again, that's first mine information. And the second mine can be operated no more than 38 hours per week. So that's second mine information. So I'm going to show you the underlining here because I underlined it in blue so you can see this is the blue information that's just for mine number 1. And then mine number 2 I underlined all in green. So we're kind of chunking the information out and dividing it into the 2 different mines here. Because that's also part of how we're going to write these constraints, because the 2 different mines have different constraints based on operating cost and time. More the hours actually is the constraint. So overall information, we do have some information that's just for both. So that would kind of be coming back up here. This company must produce at least 420 tons of regular grade and 450 tons of low grade ore per week. So that's just kind of overall information. It's not necessarily specific to either one. And let's see, we have the question being asked. So that's definitely an important one because we want to know, what am I being asked to find? There's a whole lot of information here, and if I'm not paying attention to what I'm being asked, then I may be going in the wrong direction. So The question here is how many hours per week should each mine be operated to minimize the cost? All right, so now that we've kind of chunked out the information, let's go through and start filling this out. So we have to identify our variables. So we have the number of hours the first mine can be operated, the number of hours the second mine can be operated. So we have X and Y. They could be any variables. It doesn't need to be X and Y. I just by chance chose X and Y. So X is going to be the number of hours for the first mine, and Y is going to be the number of hours for the second mine. Because those are our two variables on, we already know how much ore they make. They make 6 tons of regular grade ore, 18 tons of low grade ore at the first one. I know how much the second one makes. What I don't know is how many hours they're going to operate for the first mine and the second mine. That's what we're trying to answer the question here. So the operating cost for the first mine is $19,000 per hour. So remember, it's per hour. And since I just said that the first mine is X hours, it's going to be 19,000 times X. And that would be the cost, right? Because it cost me $19,000 to run it every hour, and I don't know how many hours I'm running it. That's what we're trying to find out. The second cost for the second mine is $13,300 per hour, so that was going to be $13,300 times Y, because Y is the number of hours for the second mine. And remember, that's how much it cost me for every single hour that I want to run this. So what we're trying to do really quick is we're trying to identify the objective function. We're writing the equation that we're going to use at the end of the problem here. So the company's total cost is given by C, meaning cost, equals the cost for the first mine and the cost for the second mine. So 19,000 times X plus 13,300 times Y. So this is going to be the cost, the total operating cost for the company. All right, so now we're going to move down and we're going to find the constraints. And I did that a little out of order because a lot of that information had to do with the with that objective function as opposed to just the constraints, although a lot of the constraints are also put in there. So we're going to scooch down here and we're going to say finding the constraints. So the first, we note that X and Y are non-negative. Why are they non-negative? It's because they represent number of hours. So we can't have a negative number of hours that we operated the mines, right? They have to be positive. So both X and Y need to be greater than or equal to 0. So that's an immediate. As soon as I know their time, they represent any kind of time, it's got to be more than 0 or equal to 0. I can stop operating the mine or just not operate it at all, but I can't go back in time. I can't go negative. Okay. The second thing is the first mine operates no more than 40 hours. So that was one of the pieces that I underline up above. That was one of the constraints they gave me. And the second is no more than 38 hours. So that was another piece that we had underlined up above. So we also know there's constraints on the minimum for the hours, but there's also maximum hours. So X has to be less than or equal to 40 and Y has to be less than or equal to 38. So I already have 4 constraints here. These are 4 different lines that I'm going to have to graph. Then there's a third constraint. There must be at least 420 tons of regular grade ore and at least 540 tons of low grade ore, which gives the following. We have a total amount of ore at 420. So the first mine produces 6 tons of regular grade ore and 18 tons of low grade ore per hour. So we're going to write this into a constraint here. We're going to have 6x plus 18y has to be greater than or equal to 420. And then we're going to scooch up a little bit again. So there's that piece I just scooched up. And we're going to have the second kind of constraint inequality here that's actually more involved than just number of hours. Sorry, losing my wording here. Is the total number of low-grade ore produced in tons has to be greater than or equal to 450. So they're doing less regular grade than low grade. So low grade's probably less expensive. Okay, so we're going to write the second mine constraint inequality. So remember that the low grade ore has to be greater than or equal to 540. I don't know why I keep saying that backwards. So the second mine produces 18 tons of regular grade ore and 9 tons of low grade ore. 18x plus 9y is greater than or equal to 540. I said it backwards again. So now we have our 4 basic constraints just based on time, the minimum amount of time it can be operated, the maximum amount of time they can be operated, and then we also have the constraints on each mind and what they can produce. So now, as you can see here, it says use a graphing calculator to find the vertices of this situation. Remember, we are looking for a minimum this time. So we want to find a minimum after we found the vertices. So once we found our vertex, I need to change that to vertices, then we're going to plug them in to find our answers. So what I'm going to do is I'm going to, nope, that's not what I want to do. I'm going to exit, and I'm going to try to make this so we can see both screens really quick. Oh, interesting, it's not letting me do it. All right, so I will just do it like this so that we can see, because basically I want to see this. So I'm going to go, I'm on google.com right now, I'm going to go to desmos.com. I'm going to click on graphing calculator here. And what I want to do is I want to start doing each constraint. I'm going to start typing them in. So I have x is greater than or equal to 0. And if you noticed how quickly I did that, that had to do with my keyboard commands. I'm going to change that to blue so that it matches my color coding here. If you don't know the keyboard commands to do greater than or equal to, because you can probably see greater than right on your keyboard. It's the period button, but you push shift and then greater than. But you have to click a separate button to do the greater than or equal to. You can also use this little keyboard right down here, and I can just click on these keys as well. So I have y is greater than or equal to 0. And I'm going to change this guy to green. Green. All right. So now we can see our 2 constraints. So these are our kind of basic constraints. Our solution area is going to have to be over here where they're already mixing. So now I'm going to go over here and I'm just going to copy and paste this because I'm being a little lazy and I don't want to have to redo that. Oh, it keeps changing the colors on me. Come on. There we go. Blue. All right. So there it is. I'm going to say I don't see it. So here we can see it over here. And I need to change that actually to less than, don't I? What the heck just happened? There we go. Less than. So now we can see it a little easier. I was going to say, why wasn't it popping up? So here's my line for 40, and it has to be less than that amount. And the thing with Desmos, though, is it's going to overlap. So I can still see it. The blue is still going this direction. So the darker blue is where both blue lines intersect, or both blue areas intersect. And then we can kind of see this teal color happening and this darker teal. The darker teal is where everything is intersecting already. Sorry about that. So we want to keep going with this, and I'm going to go this one, but it's going to be y is less than or equal to 38. And let's change this. I'm going to go back to green for whatever reason. So we can see it's you know, there's definitely this very dark green box starting to happen here, and that's what we want. So now the last 2, I'm just going to type the equation in. I don't have to solve them for y or find my y-intercept or anything like that. I can just start typing them in, and it's going to automatically graph that point for me. So it has to be greater than this point, or greater than this line, so it's shaded up above here. And then I'm going to do one more, so 18x plus 9y is greater than 540. So there we go. We have that last little section there. So it does start to get a little bit messy here, but the constraint area that meets all of them is, I'm going to try to highlight this with the vertices so you can see it like that. So this is the constraint area, this box where these vertices are kind of framing. That is the only section that actually meets all of these constraints. And there are quite a few constraints on this problem because we have constraints on minimum time, maximum time, and then also both minds have a specific constraint to them. So there's a lot going on in this one problem. So let's go back over here. And I'm going to go down to the bottom here so you can see it, because I had also done this on the slideshow. So now you can see that same graph. I just pulled it up here so that we can actually kind of see what's going on the problem, and for some reason that wasn't refilled in. So there we go. We have our 6 constraints, and here is the graph. So the vertices are 1138, 2216, 4010, and 4038. So what I want to do is go through and plug each vertice in to that objective function we wrote at the beginning to see which one is going to be our minimum. We're looking for a minimum, and I have to plug in I have to do each vertice. I can't just do one and stop. So with this one, 19,000 times 11 is 209,000. 13,300 times 38 is 505,400, and then I'm going to add them together to get 714,400. So we're definitely dealing with bigger numbers, which hopefully makes sense. If it's 19,000 per hour and I'm operating for multiple hours, that number is going to get pretty big pretty fast. Same thing with the 13,300. So I'm going to go to my next vertice here, and I'm going to do the same thing. I'm going to plug it in. So I'm going to multiply by 22 for the 19,000 and 16 for the 13,300. So I get some nice big numbers, and I'm going to add together. So this one's actually smaller. So if we're looking for a minimum, so far I'm on number 2. Number 1's not going to be the correct point because that's 714,400 is bigger than 630,800. And then we're going to go to the next one here. So I'm going to plug these in, and I'm going to multiply. This time I'm multiplying by 40 and 38. So hopefully this makes sense. These are probably going to be the bigger numbers because these are the bigger ones that I'm multiplying by. So I get over a million, 1,265,400. So that's definitely a very large number. That's going to probably be my maximum amount. And now I'm going to plug in 40 and 10. So I'm going to multiply by 40 and multiply by 10. It's 760,000 and 133,000, and I add together and I get 893,000. So if I'm looking for a minimum, it's going to be this second one that I tried. That's the result with the smallest cost. So that was the question. If we kind of go back to the word problem, if you look at your page, it says how many hours per week should each mine be operated to minimize the cost. So this is the minimum cost. The actual answer they want us to type in this time is the coordinate. So remember, X is the number of hours for mine 1 and Y is the number of hours for mine 2. So it's 22 hours for the first mine and 16 hours for the second mine. So they are asking you to specifically go back and plug that in. So we can see it here. We can answer that question. So since it's 22 and 16, I have 22 and 16 for my hours. So make sure you go back and you answer the question correctly, because I know on one of the questions it just asks us for the minimum or the maximum, but this one's asking us what are the actual hours that they would operate. So first we identify which one is the minimum, and then we look at the coordinate. So a little bit more involved when we go to the word problems there, but I hope that helped, and I will see you in the next video.